Okay, so um, let's go over the basics of Filecoin Virtual Machine again. So the Filecoin Virtual Machine, Filecoin as a storage and retrieval capability can be thought of as the base layer of the Filecoin blockchain, right? So there's Filecoin storage on the Filecoin blockchain that has access to the file storage capacity and capabilities, and the retriever to retrieve your file on the blockchain, on the Filecoin blockchain, right? FVM can now be thought of as the layer on top of Filecoin that allows you to programmatically access these abilities on the network. So instead of so programmable storage, something called programmable storage primitive. Um, other blockchain have smart contract capability. So, but they don't have access to Filecoin storage, right? So it's very expensive and data compute intensive to access data on like other if you are writing smart contract and have access to other decentralized storage, right? Compared to like using FVM, right? So there are different ways to access to use this FVM programmatically. So we have the Watson base. The FVM is the Watson base. Okay, so on the Filecoin doc repo, you go to the fundamentals, smart contracts. From smart contracts, go to the fundamentals. And you are on the FVM. We've talked about the frequently asked question, and you don't need to go by ERC20 again. If you're a beginner, if you still don't understand, you can go by this ERC20 quick starts guide. It will give you a basic this thing for you to know. So we are going over FVM now, so that because some of us have been asking question about the EVM and the FVM and the different and all of that. So FVM is a WASM based web assembly based polyglot, meaning that many language execution environment for IPLD data, meaning that FVM give developer access to IPFS or IPLD data primitive and can accommodate smart contracts, also called actors in Filecoin, written in any programming language that compiles to WebAssembly. And we also have,
I have a question.
okay,
So, does the actor also mean like minors?
eh? Actors are smart contracts.
The smart contract.
Yes. You know, the way Solana code their smart contract programs. So actors are smart contracts. We now have built-in actors. Built-in actors are like primitives on Solidity.
No, like in in Filecoin virtual machine. So the miners and miners, you know that like they are consensus mechanism.
Eh?
They are consensus mechanism.
Eh?
So they are miners. How does that work?
So
Because now,
this is
like when I check their bills, they have like proof of storing
data.
data.
Yes. Yes, proof of stake. So now there is the Filecoin network. Those are the one. Those are what the proof of storage provider. These are the people that the node runners, the miners. These are the people that have that use that. As developers, there is now FVM that is built upon on top the Filecoin network, and that's what it's trying to say here. So Filecoin storage and retrieval capability can be thought of as the base layer of the Filecoin blockchain, and FVM can be thought of as a layer on top of that Filecoin that unlocks programmability on the network. You get? You get?
Programmers to build on
Yes, to use those storage. Yes, yes, to use switch prayer. So actors are smart contracts that you now actors are what you write to now use the FVM capabilities. Do you get that? So um so these are the ways to like write these actors. We have the Watson based execution environment, and for us that we write Solidity, we have the FEVM compatibility. Are you an Ethereum or Solidity developer? You can build the next lab on FVM and use the Filecoin Solidity library. Learn more about FVM in Ethereum runtime and Solidity compatible in the next session. VM agnostic. FVM is due to be VM agnostic. That means that is built. So FVM does not really it's not really just compatible to EVM. It's compatible with any virtual machine, right? So there are also other blockchains that uses virtual machines to run their that works like on a virtual machine. So FVM is built to run on any virtual machine. So in the future, if there's any blockchain that you need to add that needs to be compatible to FVM, FVM has the capacity to run it. But for now, the main virtual machine that is still compatible to is the Ethereum virtual machine. That's why we have the FEVM. Yes. So basically, FVM brings user programmability to Filecoin, unleashing the enormous potential of an open data economy through various applications. So the different use cases for those that have been needing ideas to use to build or something like that, these use cases for FVM actors enable wide range of use case to be built on Filecoin. Here are just few potential examples. Data access control. FEM actors can enable a client to grant retrieval permission for certain files to a limited set of third-party Filecoin wallets address. Data DAO, data DAO, perpetual storage. You can read more about this later. Replication, right? Replication, leasing. You can lease out storage and all of that. So you can check out um, the different way of building on like ideas, use cases. Use and just record. So you get like the different use case for FVM. So now you start building on FVM and let's see. Let's see what this. So this is the FEVM. So best practice for developing contract. They have best practice you can check out for developing their contracts. So the next page you'll be going to from the FVM is the Filecoin Ethereum and Filecoin EVM runtime that we'll be reading. Filecoin EVM. We get that before we move on. We'll get the basic understanding of what FVM and FEVM does now. You just to get it.
This game like where but yeah.
Does anyone else do not get what I just said now? You don't have to tell me you understand you don't shout so that we can go about it again.
You don't have to go on that. This is still something I have to take into.
So please read okay, let's do it like this. Read on it. Read it again yourself, right? So understand FEVM. It's just for me. I would be just for it actually. So read it again for yourself. Uh, so basically you get like best practice in smart contract um on FVM. So you can read this later and they have a quick start for FEVM AR20 quick start. Before we go there, there is a reference implementation of the Filecoin virtual machine. So you want to read how the virtual machine is working. One way or the other you need it. One way or the other we need it. Right. So this one, let's pay attention to this because this is where we are dwelling on. Let's pay attention to this. Filecoin EVM runtime. So we know EVM, the Ethereum virtual machine and execution environment, initially designed and built for running and run built for and run on the Ethereum blockchain. And EVM was revolutionary because for the first time, arbitrary code could be deployed to and run on the blockchain. Code deployed to EVM is typically written in high-level language Solidity. Other languages such as Viper exist. This high-level Solidity code is compiled to EVM bytecode. This is what is actually deployed to and run on the EVM. Due to it being the first virtual machine to run on top of the blockchain, the EVM has developed one of the strongest developer ecosystem in the Web3 to date. So, Ethereum Virtual Machine, Filecoin EVM often refers to as FEVM. It's Ethereum Virtual Machine virtualized as a runtime on top of the Filecoin Virtual Machine. It allows developers to put any existing EVM-based smart contract straight into FVM. The Filecoin EVM runtime is completely compatible with any EVM development tools such as Browning and MetaMask. Interacting with the EVM-based actor easy. This is because Filecoin nodes offer the Ethereum JSON RPC API. So for a deep dive, you can watch this presentation, which we cannot watch now. But I'll put it on the Telegram now. So I'll put it on the Telegram group now. So so I would push it later most of time. Let's keep it at now. The roadmap. Suppose we're asking for roadmap. So now, wait, the roadmap is not for us to read. I think this is the roadmap of what you can do with LVM.
No, I think this is, yeah.
Yeah, that's like that. I think this is the roadmap, their own roadmap.
Okay. That was when we tried to launch.
Yeah.
Uh,
So
so when you're working on a project,
so 2023. That's been a while. Should have updated it. Should have updated it. So now, then in the in this space, we move from smart fundamentals to Filecoin EVM. Am I right? So yes, Filecoin EVM. So let's start from the README so that from there we'll move.
so as you're building a project, remember to just make just as you have your README, you make your directory whatever you're building, what's the roadmap, how is what's the plan, okay? You get conceptualize during the now. Okay, in 3 months time, what do you want to do? In 1 year time, what do you want to do? So you put it's like it's not an updated stuff guide, or you can see the way the FVM thing, this is the project, this is the roadmap, and this is what it works until they actualize this project. So whatever you're doing, the judge want to see everything, even the investors want to see your plan, or is it just the hacking and then you move to the another hacking? Nobody wants to see that. They want to see that whatever you're doing is being scaled. It's not just like a run-up.
Okay, so let's what's really deep with Ethereum. The difference is the Filecoin EVM runtime with Ethereum. So one, so that we can do the working knowledge of how the Filecoin this thing works. I know some of us that were still learning Solidity, we might still be having some hard time grasping the concepts here. But just pay attention. Pay attention to what we're reading, and also go over it later, right? So Filecoin charges Filecoin gas only, so it doesn't charge exchange as gas fee. And instead of EVM runtime, FEVM runtime charging gas according to the EVM spec for each EVM opcode executed. The FVM charges Filecoin gas for executing the EVM interpreter itself. We'll read out the gas work soon. Importantly, this means that the FEVM runtime gas cost and the EVM gas cost will be very different. EVM and Filecoin gas are different units of measurement, are not one-to-one, purely based on chain throughput. The ratio of Ethereum gas to Filecoin gas is about 1 to 44, except Filecoin gas expects Filecoin gas number to look much larger than those in Ethereum, right? Because Filecoin charges Filecoin gas for executing the Filecoin EVM runtime interpreter. Some instructions may be more expensive or cheaper in FEVM than they are in EVM. EVM instruction cost can depend on the exact FEVM runtime code path taken and caching. Filecoin gas costs are not set in stone and should never be hard coded like you do in EVM, right? Sometimes. So future network upgrade will break any smart contract that depend on gas cost not changing. So gas stipend, don't need to add. What's gas stipend about? Gas stipend. So I think this is like the amount of gas you need.
So for transfer, like for for transferring in smart contract. So for transferring just 4,000 Ethereum credit. That's so I think so. It's not saying that for
This one has more
it's like
stipend.
it can estimate the gas.
Okay. So self-destruct. FVM emulates EVM self-destruct behavior, but it is not able to entirely duplicate it. There is no gas refund for self-destruct. On self-destruct, the contract is marked as self-destructed, but it's not actually deleted from the Filecoin state tree. Instead, it simply behaves as if it does not exist. It acts like an empty contract. Unlike in the EVM, in FEVM, self-destruct can fail, causing the executing contract to revert. Specifically, this can happen if the specified beneficiary address is an embedded ID address and no actor exists with the specified ID. If funds are sent to a self-destructed contract after a self-destruct, but before the end of the transaction, those funds remain with the self-destructed contract. When you start building, you need to have an idea of all of this. I don't even know what that means. Yes, the call code opcode has not been implemented. Use newer delegate opcode. Now I keep saying that we need to know what opcodes are, right? So this precompiles is something like here. So we need to know Ethereum opcodes are. If you search it, let's see. I think I read it one time like that. So I remember a slab I was part part of our doing something around it. So uh, Ethereum opcode list. So basically, Ethereum opcodes are basically like instructions that defines how the virtual machine works. Like they are they're basically what makes Ethereum virtual machine works. These are the opcodes. Like there are different instructions, different specification to define how each functions you call the built-in primitive data works in Ethereum virtual machine. So you have to have you might not need to know everything on it, but you have to have an idea of those opcodes, like at least the ones that pertain to Filecoin. Yeah, so you have to have an idea of that. So you can see there's a storage opcodes. So they have like different ones. So you can so when you do like web3.cth.get storage at this address, it is this storage opcode that you're interacting with. Do you get that? So I know we might not fully understand it now, so you can read through the document later. It looks daunting, like it looks technically daunting at first, like it's very technical. But if you read it, just like basically try to read it, you should get it. So Ethereum has one block hash. Ethereum has one block at every height. Why Filecoin can have none, one or many, usually around 4 to 5. This means that block hash instruction behave a bit differently in the FEVM because there can be multiple blocks at any given height. Block hash block hash returns the hash of all the concatenation of the CIDs of all the blocks at the requested height, because there cannot be no block at any given height. If block hash is called on an height with no block, it returns the block hash of the preceding height with blocks. Can you explain it, Robert? This block hash thing. Read them, read them, read them.
Ethereum has one block at every height. Why Filecoin can have one of the usually have so block hash instruction gives a bit different from Filecoin EVM. Okay. Because there can be multiple blocks at any given height.
I need to know what height. I know that the blocks are like the each node, the singular this thing on the blockchain. So what are heights? So we need to see like some of the things we need to read on. So there are more. These are like the difference between like the Filecoin Ethereum and like the FEVM and the EVM. So another thing we need to now know is precompiled, because these are very important. The FEVM, unlike Ethereum, does not usually enforce gas limits when calling precompiles. This means that it isn't possible to prevent a precompile from consuming all the remaining gas. The call actor and the call actor ID precompiles are the exception. However, they apply the pass gas limit to the actor call, not the entire precompile operation. So,
Okay, so it's saying that the height of a block indicates its position in the blockchain.
okay, the address
Yes. So it's calculated based on its distance
to the Genesis
to
block.
the Genesis block.
So that's the height. Okay, makes sense. In Filecoin, so multiple address. In Filecoin, contracts generally have multiple address. Two of these address types, F0 and F41, blah blah blah, blah, can be converted to OX style Ethereum address, which can be used in the call up. So I think when we copy the contract address in our first project that we did, like the first tax, I remember when I was checked to do it, it showed that one of the document I was reading showed there is a way Filecoin addresses are written that is different from Ethereum addresses, right? So Ethereum basically have these two of these address type. We'll read about address types to here later. So we should read more about this while we are building. All of these seem, like I said again, they seem very a lot of English and everything. But as you're writing your smart contract, you get it. So yeah, so actors type. I think okay, let's see how gas works. So you can read about how gas works. You need to read about how gas works to start writing smart contracts real time on Filecoin. Right? I've and one of these I'm saying we need to like read all of this so that when we start reading, because I want us to read the Filecoin project, like we'll start for like a Filecoin smart contract on GitHub, right? So that like an example smart contract to see how it looks like on a normal deployed smart contract, how it looks like generally. So for some of those times that we need gas estimation, like I think for some chain abstraction or something like that, Filecoin fully is also provide Ethereum compatible APIs to support gas estimation. So you can do gas estimation and all of that, right? And I think Filecoin has its own tool, this thing. Let's check it. There's FIPs. You can read them basically. They are like I think these are like ERC, ERC. What's it? What are you? What's the name of this? See, something like that. So they're like guidelines and like different. What's the word now?
But then, I would be debating the ERC 20
No, you're having FI. You're using FI token. That's what I'm saying. That we will need to like know about. You like going through all of these documents. Like forget forget their website documents. Check this GitHub documentation and all that we need. while writing like this. Eh? That is why it's this is for like that's why it's on GitHub, right? You search on it.
That's why
That's
research.
like
Even if you are doing like because if you are doing something like this, like you are building like you have to do research because there's updates every time.
so. Let me tell you. Let me just put it like this: a average like technology you use in tech, they still have document. They have MD documents. You have to read their code to understand. I remember during Web3 Lagos that there was some people who were using one of these. It was in one of these. They were building like or something they were building. So they had to they message their people. They couldn't even get any documentation. When the Meg got access to them, a root stock. They sent their code. It was their code base. They sent to them to go and fight to it.
People start with
Yeah. And so at least they are even very lenient. You still have documentation in their GitHub. You are not reading one archaic code. I cannot even know the roots.
Documentation that will teach you.
I don't work with it. I'm starting with
So that's how it is generally. So get used to it. There is no the more like I said, most website documentation is mostly for I won't say marketing per se, but it's just for information, just like a overhead idea. It is when you now open the code base, you now see the deep dive, right? So in the website, they'll tell you that you can use Ethereum, use fully ERC compatible. But it's in their code base that you know that there are some parts that you still need to be wary of, some parts that you need to know. Do you get? So let's read actor types because actor types are like the smart contract types in like in FEVM. So there's actor type. In Filecoin network, an address is a unique identifier that refers to an actor in the Filecoin state. So all actors in Filecoin have a corresponding address which varies from the different usage. So I think this address are like the contract address. Like every actor, every smart contract has its address in the Filecoin this thing. So the FEVM introduced three new actor types: placeholder actors, Ethereum style accounts, also called ETH accounts, and EVM smart contracts. So a placeholder is this particular type of pseudo actor that holds fund until an actual actor is deployed at a specific address. Ethereum style accounts. I'm shift screen. I'm sieving through all of this so that we read on our own, right? Because of time. Ethereum style accounts is the FVM equivalent of an account with a F1 or F3 address, also known as the native account. However, there are a few key differences. Blah 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 blah. You read it. So EVM smart contract actors. Every smart contract will have a OX style address. This was the one we worked with. This was the one we worked with. That's how we integrated our smart contract. You see, like this contract address was like OX, starting with OX. So it's saying that there are three different types of addresses, or in other words, three different type of actors, because the address are like pointers to those actors. So there's the Ethereum style account, which would normally start with like F1 or F3, which is like the Filecoin address system, right? And now we have EVM smart contracts style address. So an EVM smart contract can be deployed in one of these three ways. An existing EVM contract can use the EVM create and create to opcode. I've seen opcode again, right? Number two, Ethereum native student can be used in conjunction with an Ethereum style account, such as Remix or Hadat. A native account can call method 4 on it. I don't know what this is, right? So we just right. Right. So then Ethereum can be called in one of the three ways. It can be used in EVM call code, MetaMask, and finally native accounts, right? So I think those are the type of actor types. Then address types. There are 5 address system. So we need to like have an idea of it because you'll be working with them, the wallet address, delegated address, sites will be working with, right? Then lastly, I think that precompiles. Let's just have an idea of what precompiles are. So I've been seeing over and over and again. A precompile refers to a pre-existing piece of code or smart contract that is already deployed on the Filecoin network for use by the developers. I'm guessing the precompiles are like libraries, something like libraries, right? Huh?
Yes, yes.
And I think they mentioned built-in actors. Built-in actors are like standard libraries that come from Filecoin. Like yes, they are built-in actors, standard library. Then precompilers are like libraries that people have already. I think like Open Zeppelin, you know, this like Open Zeppelin library that are using like Solidity. Yeah, so these are like compiles on FEVM. So so they said every precompile, like I said, every actor has its own address. So each compile precompile address starts with OX. So when you see OXFE000, it means that it's a precompile address, it's a library address. So yeah, you can read more from there. Huh?
It's already declared as a fixed address in Nigeria.
Yeah, so like you're already there, so they're like yeah. So you can check them later. So that's that on the theory part, theoretical part of reading on Filecoin FEVM. So deploying contracts. Let's start with deploying contracts. Uh, how to get text token, how to set up remix, how to set up add that.
So for the foundry and others, which do you think, like, which one do you think we should pick one? Can we use foundry more or we should use others more?
To be honest, mostly I'm used to have that.
Which that I'm asking because most times people say they prefer using foundry.
Huh?
Yeah.
So some people prefer Foundry, I mean.
Foundry.
I think we should just try to use the two and see which one is easier to use. You get? Yeah. Let's see how to make use of Foundry. Oh? Foundry needs Rust. Yes. See now,
Okay.
Forge is a Rust. I know that Forge is a Rust too. You go learn Rust, and I think Foundry has more extended documentation.
No, that's for building. Just for
It's just a tool. It's not. You're not writing Rust. You're not writing the Rust.
that's for building a distance.
Yes, it's for building. Yeah, yeah. You don't use Foundry before.
I don't know.
Which one is easier? Adapt or Foundry?
That. But it's 100.
But which one is?
Well, Foundry is better. Actually, Foundry is easier than Adapt.
Adapt is still easier to
The only thing I hear about
Foundry is easier than Adapt.
Yeah,
Foundry
Me,
is
I
just
would-
like
I
how
would
you
try
write
it
smart
out.
Foundry
contracts.
Foundry is very it's complicated somehow. You know this Adapt now that we just did the MMTS and
No, it's because you've not been written test. That's why you think. That's why you think
when you
that.
start writing tests for foundry, you know what's
Okay, when you start writing tests,
No,
yeah, that-
Even in that, Foundry testing in Foundry is better than because like when you write Foundry, it's just like you read it.
to make you write
You
500.
know, it depends on the ecosystem you are building.
So I think they have like a guide on writing on Foundry.
Foundry is
You
better.
can check it later.
For me, I never learned.
Okay, so yeah, so there are contracts templates that you can use for range of third-party Solidity library that you can use on this thing. So these are the Open Zeppelin. This thing you can use in Filecoin. So I will see none of this that we need. So there is also calling built-in actors. How to call in built-in actors. So this one you have to read them by yourself. They are very, very somehow. So these are this. So deal making, how to perform storage deal. I think this deal making thing still keep coming up again. Okay. So this section covers how to make use of Filecoin Solidity. Okay. Oh no. Back. I'll dive back again. Okay. So let's get started. This is how to verify a contract.
I'm going to check.
Check on average.
You go use few forks. Let's use the remix. Let's open remix.
Yes. Yes.
Yeah, Solidity, except VM. Except you want to go the hard route of using Rust. And you say you don't want to like
If you use it.
Who the right trust?
Who the right trust?
The right trust.
The right guy. And
I think so okay. I said in the File Explorer tab, in fact, under the contract, I click on the contract you want to verify, generate URL, UML. Let's this ballot this ballot contract. Let's use it. Generate UML. So it has generated the UML. So from the to flatten the financial document. Yeah, that we read earlier. Click save. See the new kidney will come out. Eh? We go.
Okay, I think we can save one minute.
Eh?
Go back to it.
Artifact.
Go back to the documentation.
Huh?
Go to the documentation. Okay, let's follow this step by step.
So generate UML. After it generates UML to flatten the file and ensure that our component and tags are included, a new contract will be generated below your original contract. So let's use our example one. This one.
No, I think you have generated. You are not just saying.
Huh?
You did just say it. It's generated, but that's
Okay. Let's try again. Ballot tab, generate UML. So how do I save it?
look at those three icons. Four.
Go to that first one.
Check your top left.
Down.
Slow down.
Check out.
Undo.
Huh?
Click on plus and minus.
Okay.
Download the game. I think we try downloading that email.
This is not.
Sorry. Okay. It's not to flatten. It's the flattened this thing. This is just the AML. It's not the flattened this thing. So okay. So let's go back to our documentation to see what this is. So generate UML to flatten the the so file. I'm sure that all the component and tags are included. It's generated below your original contract. So we're meant to have like a something that flattened file here. So let me save it. So what you see.
What if you guys click on that generator right?
Let me download it. The UML is entirely it's the UML that are downloaded. Okay. Okay. Uh, like we go figure this one out ourselves. Could do this one later.
No, let's go to the discussion. Let's
Eh? Eh? Tonight, sir. I know they sleep again.
if that's
Say again. Okay. How can we do it without using a remix?
That's true. So like let's scroll down. Suppose that's two talks. So we have to. I don't think we get for like.
We go search them. We go search them. Since there is this current document, because the last time the document was edited, just like from that one is 2023, and yes, that was so for example, some of the RPC has changed, and so a lot of things has changed. So I'm guessing this method doesn't work.
This is the way teachers this in the group now.
Eh?
This way teachers we teachers that in the
In the
group.
yes, it is in the group. It's on the group. What's his name again?
What's the name? Sabine.
I see
What, sorry, sir, what's the method now?
Timmy. Yes, I think Timmy.
Okay, you want to ask that one?
Ask him. I just want to show you the name.
What is the class president?
Timmy Brew. Eh? She know the right speaker. Eh? Just one motivator. First, home in the win now. You go Madrid house now. You go anyway you buy people for their house.
Now first step.
And I felt like that their house is second leg now. Yeah, now.
And so
If they go Madrid house, no man. That's what they thought. So 5 minutes. So so add that. So using add that. This is what we've done. We've done this one, right? So using RAS. What's RAS? Renew as a service. I just renew. Storage renewal. The FEVM, yes. Client contract tutorial. Yes. No. I'm still. So that's that. So next thing I want us to do is I want to check for a project, a smart contract on FEVM. Is like Explorer. I don't know. Yeah. Filecoin, yeah. I think it's like a task count for Filecoin now. Something like that. Maybe. Wrong person.
No.
Okay. They laugh.
I don't like laugh.
Okay, Filecoin EVM contract. Stop. So they come back. Okay. So this is a file FVM asset manager. This is a tool to manage assets in the FVM system. a smart contract factory which can create reward splitter on the go. One can use this to create a reward splitter for a new asset, then use the splitter to distribute reward to the asset holders. So this is a project on FEVM. So let's check it together. Although it's 3 years old, but it should still be able to be functioning. Ba, 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 what license is it before you start tapping on your code? You don't get license. Okay, so let's check the package of JSON first. Entrance to the Next.js. They use Next.js. They use Spline too. So animation, basic UI, so tailwind, NFT storage, built on Filecoin, swiper, Wagner was 3. So on chain kit, what else? That those we need to know. Then contracts. Maybe I know it's not on chain kit, like two. I get what I'm trying to say. I know there's one choice. So split factory. So this is the contract. It is the payment splitter on Open Zeppelin. Uh, Struct split, total split address. Okay. Does someone want to explain this contract? Over. We can do this at the end time. Let's explain this contract.
Yeah, of course.
This is first the that's how it structs. We just assume
Just explain like we give you like you do the money.
so starting with the struct, just assume that the struct carries its and checks for the address, which is then maps the address. That's one thing. Split the database, split it. So it also has an event like 12
What's it meant?
events. So the event like basically taking the address, the index address from line 10. Line 10. So the line, I would say,
We just like
the line 14. We're asking about which one? Then
Events. What does event do?
basically talking about the how do I say this?
like
Just like what
in
the
this context or like what events
What are events?
generally generally do. So events it's just like a notification. So like when you are using events, it's like when you are using events and you are interacting on your front end, it's just like maybe I'm transferring, maybe someone is transferring from your contract. It's just like you are when you are emitting the events from your contract. So like to be triggering your front end. So it's just like a notification that this event is occurring.
I don't know. That's what I'm reading here.
Different things.
Almost the same, but not exactly. Events play a crucial role in creating transparent and auditable smart contracts by providing a way to communicate and record important information on the blockchain. Events are a way to log and notify external entities, such as user interface. It's almost the same thing, but like as they talk, say notification. Okay. So events are similar to logs and records that capture, and events are gas efficient. So that is made by events. So the event is so that index. What does index do?
So when you are using
like list.
Is it list?
No, I think it takes means
So-
like the first person.
This is not index from React. Though.
So index is just like maybe like if you are using normally if you are how can I put it? if you are emitting an event of like maybe if it's having two arguments, so you have to be using index. But I don't really know why.
I think
Okay.
uh,
I'm coming now. Okay, so it is used with events, this event keyword. So it is used the index ac- in Stack Exchange. We allow you to search for this event using the indexed parameter. So I think it's for when you need to like check for this what's the word, to check for this to use this event. Yes, so I think this creator will search for the in this
For this, we look for this creator inside
different
created
switch, yes, and this splits we look for this, like it's just like a tag, more like a tag, index to target. So then continue.
I think it becomes the address once it has marked from so, so it returns the address then payment splitter. I know this one.
Hmm?
Payment splitter. That's it. I think that's the contract. That's the
Okay.
So this is it. I think so. The function to create the split, it passes like the address of the payee, the person that is paying, and the shares in number, the amount is being paid. So it returns the address. Then the payment splitter is this third party. This thing is generated, it's installed, imported. So it's a new splitter. The third party splitter, the third party app does the splitting. Then this split database, this map, it's the message, the sender, the total split increases. Then it pushes the address of the split. This was the split now. The split is this index here, right? It pushes it to this split address here, and it emits the indexed, it emits this event, the message, the member access and the address of the split. Then you return the address. Then it's saying that this, you now create a new contract split. This capital split is inheriting this payment splitter. Do you get?
Yes.
Do we get? So then we have the constructor. So this constructor now does the main work, right? So I think that's that for the smart contracts. Let's go back to this thing. I think what else? Let me see the hooks they used. Huh? So this is the hooks they use to use the smart contract, the chain ID. So this person life, they add code smart contract address. So please, it should be done. After the reviewing this, we are done most of the time. So please don't do this. Don't do this. Always use environment variable. Don't do this. Don't put your address in your code, because there you have real money in your address. They hack your off.
It's fun now. You just want to keep up.
Eh?
You just want to keep up.
This is your contract address.
You don't need to have the change. It's talking about your wallet address. That's your wallet address. You don't need to have the that's what it says. You don't have it. Your this thing. Tell me that. What are you saying, Olamide?
See, no argument, no point of argument. Don't put any address, any personal this thing in your code base. Put in an environment variable.
Use your contact and they can hack
I think this guy is
Because
talking
I'm
about
dealing
the deployed contract address.
No, he's talking about like wallet address,
Wallet address, like
it seems like it's only private key that we can be hiding.
Okay, wallet address to private key.
No, I sabi that I account. So the person sabi your wallet. There's nothing. Yeah, I'm just saying. There's nothing. There's nothing there in your wallet.
Okay, they can act it or not. Make it a rule. Even in normal programming, anything that is private, put it in your environment variable. Okay, put your wallet.
I'm not joking.
yeah,
It's not funny,
say
bro.
it's public address. Wallet address is a public
This
address.
is a contract.
Really?
This is
On
the
your
contract.
normal-
So this is your contract address. This contract address is pointing to your smart contract on chain. So if you are doing anything that is serious, when you put this code on open source, if you are running your own what's the word? Your dApp, your own dApp, and you are running it. Once you put your contract address like this, I have access. Even if you secure your code, I have access to your ABI function. With this, I can have access to it. With this, your contract address. This contract address points to your smart contract. You get that? So put it inside your FEVM file. Always.
Oh, yeah, a good programmer, right? You're not supposed to put your.
Yes, that's what I'm saying. Basic rule. That's what I'm just trying to say.
So okay. Let's say we're trying to like create a review.
Wait.
Regarding your wallet, managing your wallet, you should have a separate wallet for development. Like how we want separate for private for personal. So you can just split it out.
So my question is, according to this now, I think they're trying to like create.
Let's make it the argue.
This meetup now, the other day I was address.
Na newbie, na maybe hackathon, something like that. So chain ID, they still create chain ID just to, and the same chain ID they still write down, add code them into the code. The newbie, it's constant. Yeah, they still add. That's what I'm trying to say. So why is this weird? Is that is the ABI of your? Let's leave this matter. Let's finish what you're trying to say because we argue this. So now you see, can we all see? So this is what when you deploy. So when you deploy, see remix. Are we here? When we compile, please are we here?
Yes.
We can leave argument later. Please, your wallet address. We will do them later. When you compile your contract and come here to deploy it. Yeah. So when you deploy it, it generates a ABI.json, right? Yeah. When you deploy it, it generates ABI. Yes. So it's the ABI that your your front end interacts with for integration. So where's our code base now? Okay, this one. Wait, so let's finish what I'm trying to say. So you see, so wait, so can you see it? Can you see it? So this is the ABI that will be generated. That was generated for their code. So for each of their contracts, for the split contract and the split factory contract. So this is what they use. You are not writing this. It is generated. You just copy and paste. Yes, once you deploy, it's generated and you just copy and paste it here. Then they use it in there. Do they have any serious thing they need to use? Okay, so they have it is claim so ban token. So these are interaction with the blockchain that they use. So you can read the code base yourself later. Should I put the code? Do we need to read it? So you can just search for it later yourself. There are a lot of them. Just search for it. There's not any special code. This one self. There's no any. No, you search for it. I search for it differently. It's another person's code. So that's it for tonight.
So what are we doing tomorrow? Are we like going?
From now on, just if we have question, start building on Filecoin. I think even though I rushed it tonight, we've done like understanding of FEVM. I need to do FEVM. The remaining there's no shalaye that can be done. Me too, I need to build. You all need to start building. So tomorrow we are having like after our class tomorrow, we are going to I'll see is it is there like are there like project ideas we can ask for like learning project ideas?
Yeah, I think we should. Sign up one yesterday.
Okay. That we can use and maybe we can have like guides that we can check in case we need like help or something like that. So maybe tomorrow at least every one of us will build a simple app, a simple dApp tomorrow.
Wow.
Yes, everyone. Not stack, so this is just on our side evolution and whatnot. I'll do it tomorrow. And we'll integrate it also. So if you don't know front end, just know that you know JavaScript, you can write JavaScript. You can write JavaScript now. So we'll do you know it. You know it.
You will need the person who will write smart contract.
No, so now we are learning so that everyone can be impactful in anything we are. You have your strengths, everyone have our strengths, right? Even if you are a generalist like me, you still have your strengths. But at the same time, we need to have like we need to like personally build all of these things. You are in hackathon team, but if you get a job, you no go send hackathon team. The one you dey fight, say they send you. If they write front end, they don't send you. So that's just it, right? And as this thing tomorrow, we're not using ChatGPT. Make it as a personal this thing. I'm not using ChatGPT at all to generate any code. If you are going to solve any problem, we'll go to Stack Exchange, Stack Overflow, the old way. Yes, it's the old way we are using. That's what we are doing tomorrow. See, let me say why we are doing it. We are learning, like I've said. We can decide to use ChatGPT on our own when we are building our project, but you will not learn. You will not know what's going on, right? How many of us use ChatGPT for our tax? I used it, make I no lie, and I don't know how to the tax too. I just had to sit down myself to learn it again to understand it. A lot of us do not even know what's going on in tax too. I will not even tackle that one. That should safe. Never tackle that one self. So tomorrow we'll read the app. Over time, if lighthouse storage comes up in the project you are building, we'll now talk about that one. So that's that. Huh? So I don't know.
So now,
I've stopped sharing.